This video is brought to you by our amazing supporters over at Patreon. For this set of videos, we'll be taking the concepts discussed in our systemic game design series and putting them into practice by crafting a system that could be used in a game. A few things to get out of the way before we begin though. First, putting systems into games is as much about design as it is implementation. A lot depends on the type of game you're creating and how systems driven you want your game to be. To avoid getting bogged down in the design of an entire game, we're going to focus on an isolated system. We'll talk about the design and implementation of that system without inserting it into a full game. For those of you interested in how systems can be integrated into a full game, this is a topic we'll discuss in the future. It will just be in a format more like best practices rather than a step-by-step tutorial, due to how subjective it can be. Second, we are really focused on the functionality of the system rather than the player experience. As a result, we'll rely on Unity's own functionality to save time. For example, using the inspector as our game interface rather than creating a player-facing input system. Creating a UI or a control scheme for a game is a much bigger topic for a different series. Next, part of the paring down of this game is that I'm not going to be creating a world space for the game. Rather, it's going to exist in an abstract sense. This is going to save us from handling things like level design or AI or pathfinding in our game. We could certainly add these in the future, but for now, I don't want to distract from the system itself. Lastly, there is no one right way to design and implement a system. Don't take this approach that I'm using here to mean that it is the only or even the best way to make a system. It's just one that works for this example. I will be using some of our best practices in terms of design, but for implementation in particular, there are many ways to put a system together, just like there are many ways to put a game together in Unity. With that, let's start designing our system. For this example, we're going to simulate an ecosystem. This could be a major mechanic of a game, like a more natural version of SimCity, or be used to bring an area of a game to life with dynamic landscape and animals. The system will start with three types of units: grass, rabbits, and wolves. Grass will multiply, and is a plant. Rabbits can multiply as well, but also need to eat plants. Rabbits are also considered animals. Wolves will multiply as well, and they will eat animals, and they are animals. To start, we can look at each of these units and see what they have in common. Rather than thinking of grass and rabbits and wolves as separate nouns, we can think of them each as a type of unit, with different adjectives attached to them. One adjective that is common to all three is multiplier, which may require a set of prerequisites. For example, for every 4 grass, a new grass is created, or 2 non-hungry rabbits will produce 1 rabbit. We'll set these up so we can adjust them to help balance the system. It's worth noting that the game will be somewhat turn-based, where every time unit, which may be a second, half second, etc., will call a tick. Each tick, the game will check through all possible changes that happen and run them. This discrete time unit will help organize how things happen. Another adjective is consumer. This system will be a bit more complex. Consumers will have a hunger level, which increases every tick. At a certain threshold, the consumer unit will try to eat based on its preferences. This also necessitates a consumable adjective. Anything that is consumable will need to reduce hunger by some amount. This one is somewhat common to all three, however, so we may just build it directly into the unit itself. With all of this, we have a couple of feedback loops happening here. More units of a type will multiply faster. This is a positive feedback loop. But consumers must eat food, which reduces their food source, which is a negative feedback loop. Likewise, we're using an adjective approach, which allows us to add additional units with relative ease in the future. On its own, this system will run automatically and simulate a hunter-prey or supply-demand relationship. We may want to add a level of randomization later, so the simulation doesn't become too predictable. With these design decisions in mind, we can start implementing our system. We'll start that in the next video. In the meantime, thanks for watching, and I'll see you next time.